The second type we want to look at are the Rose curves. And the Rose curves are where you multiply a constant by sine or cosine instead of having a plus or minus in between. And there's an extra factor in front of the theta, which means we're going to get a multiple angle, like double, triple, quadruple angle setup that we had back in the trig function chapter. So we've got the a being multiplied by cosine and then n being multiplied by the angle measurement. So we end up with multiple angles. So n are going to be integers, and we're going to be greater than or equal to 1. So the first thing we want to do is we want to plug a couple of these into our calculator and see what we have. So the first one, r equals 2 cosine of 3 theta. Let's plug that into our calculator and see what type of shape we get. All these look like flowers where we've got petals, and each of the petals are one of the curves. So we want to do some investigation of that. So the first one is 2 cosine of 3 theta. And I'll go to zoom standard for this. Yeah. That really doesn't look too good, so we can zoom in a little bit. There we go. And how many petals does this rose have? You can see there are 3 petals. How large is each petal? Well, if I look at this, I can see there's 1 unit, there's 2 units. So each one's going to be 2 units. And is there any symmetry? Yes, you can say there is some symmetry around the polar axis or the x-axis. We see a symmetry right along there. Looking at the next one then, r equals 4 cosine 5 theta. So we'll go 4 cosine of 5 theta. Oh, look at that. I can see now I've got 1, 2, 3, 4, 5 petals. How long is each petal? Well, this one it's 1, 2, and if I were to continue out, I would see it's 4 units. And once again, I've got a polar axis. So it looks like there's some relationship between this 4 and how large each petal is, and the number inside and how many roses it's got, or how many petals the rose has. Let's move on to the third one. 2 cosine of 2 theta. My guess would be it'd be a length of 2 for each petal, and I would have 2 petals. Oh no, look at that. I do not see 2 petals, I see 4 petals. So something changed right there. I can see 1, 2 units out for how large each petal is, but now I see that there's 4 petals. And my symmetry, I can see that there's symmetry both around the x-axis and the y-axis, or the polar axis, and theta equals pi over 2. So this one we've got polar axis symmetry as well as theta equals pi over 2 symmetry. One more. 4 cosine 4 theta. I think my petal length is going to be 4 units here, but I'm not quite sure on the number of roses that I have. Is it going to be 4, or is it going to be something else? Look at that. It definitely isn't 4. I see 1, 2, 3, 4, 5, 6, 7, 8 petals. Each one is 4 units out, and I can see the same symmetry as in the previous one, that I've got a polar axis symmetry and a theta equals pi over 2 symmetry. So now that I've done all that, what relationship can you determine between n and the number of petals a graph has? Well, if n is odd, we know that it's going to be the number of petals. So here, since n was 3, we had 3 petals, n is 5, there were 5 petals. But if n is even, then it's the number of petals is equal to 2n. So there's twice as many. Here 2 is an even number, so 2 times 2 gives me 4. Here 4 is an even number, 4 times 2 gives me 8. What value determines the size of each petal? The a value. And that doesn't change based off of even or oddness of n, or even or oddness of a. It's just going to be how large each petal is. What pattern emerges for the graphs that have symmetry? Well, when n is odd, you're going to have polar symmetry. And when n is even, you're going to have both polar and theta equals pi over 2 symmetry. And then finally, what happens if you change the cosine to be sines? You do a quick rotation of 90 degrees. But the same relationships emerge that the n value is going to determine the number of petals I have. If n is odd, it's the number of petals. If n is even, it's 2n. And the symmetry is still going to remain the same relationships.